Okay, so something in Scandinavia that isn't working. I've switched to auto, and I think I've just gone live. I think
Yes, you
I've
have.
just gone live. Hello, greetings, happy coders. I don't know who's here yet. Probably just a couple of people, as per usual. Does it tell me? I guess I go to my own stream and see. Got myself on mute. That's all good. Right, you're on there. It says 0 at the moment. 0.
Automatic, and it's got me as Brazil.
How strange.
I haven't actually changed to anything.
Well, look, there's Ro does the solo. Hello, Mr. Ro. What's that? Was that you? Bip 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 bip.
Might be, yeah. Let me turn off. Well,
All right. Yeah. So, guys, just so you know, for the benefit of everyone watching now or later, I did a full update on Windows because I was having some problems, and so I've had to reboot a few things, and now don't know where Andy is at all, but I think I can get him back. So let me just see. Discord, yeah. Okay. Okay. Oh, you've just turned up, look.
yeah.
Just like that. Alright. That's alright, isn't it?
Yeah, there's about a 20-second lag on it.
Yeah, well, we don't pay attention to that stream anyway. That's for the
True,
chat.
yeah.
Yeah. Okay. So what else do we need? There's just Ro here at the moment, as far as I can tell. Not even sure if he's still here. Yeah, that's good to know. Okay, well, I'm gonna get a brew. Let's just give a minute. I'm just gonna get my tea. Then we'll see, and then we'll think about what we're gonna do. Be a sec. Thing is, I didn't tell my. I should have told my Patreon supporters. Really, I don't think I did. Well, I know that I didn't, which is very irresponsible. Okay, well.
I am here. I made a drink about half an hour ago and I left it in the kitchen, so I'm microwaving it.
So how's your week been, Ro? No, I'm just talking to the chat. It's so hot here in Kazakhstan. It's going to be about 35 on at the weekend. So yeah, feeling it, certainly feeling it. Just verifying. I'll send a message out to the patron now. I should have done it before really,
but sorry, back.
Yeah, so Ro, is it Birmingham that you are? Is that where you are? Just outside Birmingham? I can't remember now. Quite the week in the UK, huh? Big changes afoot.
Yeah. Are you going to be showing the game on yours?
Yes, I can do, yeah.
Apparently, we're going to get up to 37 degrees before this heat wave ends.
Yeah, that's what it's due to be here on at the weekend.
Is it?
Yeah. I was out on my bike today, I was getting a bit dizzy. Hoping we might get a few more people in this weekend. Thought it might be building a little bit, you know. But well, look, we have a couple more. No idea who they are. You can shout yourself out if you like. Ah, okay, right. So you're in Cardiff. Ever been to Cardiff, Andy?
Yeah. Got my tattoo done in Cardiff.
Oh. Got tattoos, have you?
Just one.
Are they geeky tattoos?
Kinda. It's my character from EverQuest 2.
Blimey, that is geeky. That's geek. That's double geek. So you've had that tattoo for about 10 years then? Petzl K79 I promise I'm not a bot. Well, you might not be. You might be, you might not be. Let's ask Petzl a question to prove they're not a bot.
How many coders do you see in this picture?
Okay, Petzl, why did you choose that name? What does that mean, Petzl? What does it mean? I see. You mean Petzel is your surname? The KZ97AP. That's not your surname, is it? Ah, okay. It doesn't sound like a bot, does it? It sounds all right. Okay, guys.
Oh, cool.
Well, let's get started then. Why not? So, when I say get started, what were we planning to do? Yes, just talk a little bit. So, guys, as you know, I've made a few games, and Andy has made a few games, and so we it came up in conversation that there are people that well, we would like it if people would kind of take a more critical eye on our games. And so we thought, well, why don't we do that to other people's games? You know, maybe not necessarily people with less experience, but I kind of felt like maybe between us, we had a certain level of standing, you know, in the specky world at least, and enough to, I think we know what we're talking about. So for that reason, we decided, hello Graham, hello Frozen. Frozen is Richard, I think. Please tell me I'm right. I'm almost certain it is. So, hello Richard. And we decided we'd take a look at a game, right?
We did.
Okay, so I'm gonna bring it. I'll bring the game up. We'll just put the screen up, right? And we'll have some general chat. But why is it? Sorry. What is it? You know, that kind of critical support. What's so invaluable about that, Andy? Do you think?
For me, it's like an affirmation of I guess, whether I'm doing things right or wrong. I don't want people to just be thrilled that I'm, sharing a game early with them to get an idea of, what it's like. I want honest opinions. I don't just want, yay, it's wonderful, everything's perfect. I think nothing's ever perfect. Everything can be better. So for me, it's more important to get critical feedback than it is just to,
But there is a point, though.
obviously, when you're coding it.
Yeah, there does come a point though where you just say, this is good, and I'm happy.
Yeah.
And I'm happy to move on. Right? It's not. I think that was what we said last week. It was like, aim for the perfection, aim for the best version of the game that you can. Right? Let the game be what it wants to be. Allow it to achieve its potential. Within its kind of milieu, so to speak. And sometimes you do need that it's a certain amount of objectivity, isn't it, right?
Yeah, definitely.
And there is a tendency in the community to be supportive, as in a little bit overly supportive, as in, wow, this is a fantastic game, wow, brilliant, yes, we love it, and so on. There is that, and then there is all, and there is sometimes, there are those also who enjoy doing that kind of the other way around as well, right? So anyway, okay, I've got this game up now. There we go. So there it is. Nice, right? Guess we'll move it across. Now, so we are going to talk about this game, and we're going to talk about the things that we like and the things that we didn't like. And this game is free, guys, if you want to download it. I must make sure that I give credit to the author. I know his name is Angel, and I'm just going to check. Is it Angel Carrasco or something like this? Let's take a look. Colasso, sorry, Angel Colasso. So, greetings all Spanish coders and gamers. Of course, the Spectrum was really big in Spain, although, I don't know about you, Andy, but I only had an inkling of that in the 80s, that there was this whole other scene,
Don't know if I even know about it.
Every now and again, you'd see a game, and you'd notice that the authors were Spanish. So
right.
I think, that game, that game Fred, for example.
Yes.
And which was a really good early Spectrum game, and that was one example. And I think the Bugaboo the Flea, that might have been one as well.
Yeah, I think. Yeah, was it Brazilian?
Company called Investronica in Spain,
right?
Who were big publishers. And there's an official kind of Spectrum. Spanish Spectrum,
Yeah,
and
it was.
So there's a whole scene there, and Portugal as well. But yes, I remember Bugaboo the Flea, and I remember Fred in particular, thinking, that's somebody in another country, outside of the UK, which was a little unusual because the Spectrum is so kind of quintessentially British, isn't it, really? As far as...
Yeah.
From our point of view, anyway, I suppose. I mean... So anyway, there is a scene over there then, and of course it's still popular now, and I have some good friends in that scene as well. It's much easier to communicate nowadays, but in those days it really was just like islands, where people were producing things, and you didn't really... I mean, even when you got games from America, it was like, whoa, this game came from America, I don't know if you remember that having that kind of experience yourself, but... Slightly, you're slightly younger than me, though, aren't you? Or are you?
I don't know, am I?
Well, I'm 52.
I'm only a year younger then.
Ah, right.
Yeah, I'm 51.
I see. Oh, well, it's much of a muchness then. Just
that
you were born in the 70s and I was born in the 60s. Anyway. So, yeah, nice scene, Spectrum scene. Nice loading screen here, right?
'Tis nice.
And I think...
Very Joker.
It is, yes. And I think before we start, let me just look at the chat as well. Graham there saying that he picked up some stuff in Spain. Yeah, I think they did get the 1 to 8K before other people did.
Yeah, they did. Wasn't it made there?
He's saying that there was a Pac-Man clone with a nudie woman on the cover. Dynamic, Dynamic. There was Rocco. There was like that boxing game. The Dynamic software. They're probably the most famous of all. Yeah.
Oh, what was that game that they did a sci-fi game, didn't they? With I can't remember what it's called now. I need to Google it.
But I mean, well, Spain in 1982. I mean, it was still
game over.
Still, well, Franco was obviously was gone, but he was still, he cast a long shadow, didn't he? And,
yeah, he did.
It's a different world, different Spain today than it was back then.
Definitely.
Yeah, some people are mentioning things like game over, things like this. Yeah, the our Latin counterparts a little bit more free and easy with the female body in the old video game department in the 80s, I think.
They certainly were.
Let's put it that way. Cultural differences, but anyway, let's talk about this game. You can get this game on itch. We'll have to try and see. I really should be better prepared than this. But what I would say is bufonada means slapstick, I guess, in Spanish. And Angel's name, his kind of coding name is Rolando, right? But if you go to Rolando, that's ROOLANDO.itch.io/bufonada. You can find the game and you can download it and you can get it for free, or if you want, you can also make a donation. And
I think it's well worth a donation.
Well, this is what we're going to come to. So before we actually really start talking about this game and the code and the different various things that we did or we didn't like, I think it's fair to say that overall we really did quite like this game, didn't we?
Yeah, we did.
Yes,
yeah.
We did. And we started out thinking that it was good. And then by the end we thought actually it's better than we first thought it was as well.
Yeah.
So it was a bit of a grower. So that was which is great, because the first impressions were very good, and then it was also a bit of a grower. So
yeah,
it was a pleasant surprise, actually, really. I don't think that we were expecting this game to be rubbish, because I had seen a couple of reviews and people recommended it. But it's a smart game, and it's fun, and it's definitely worth a look. So yeah, I mean, we'll start off then. So let's go into the game, and I'll put the music on briefly. So the first thing is it has like this cutscene, right? And that's really fun, isn't it? It's great to have a cutscene at the start of the game.
Yeah, something we very rarely see.
Yeah, and in this one, you actually
an AGD game.
You actually have to press the button, and it kind of starts the game like this. Now, one of the things that kind of made me a little bit worried was when I heard that sound, of course, and I thought, oh, here we go. It's the MP-AGD sound engine, the one that's in every single game. So, and the sounds are always the same, and there's like 200 games, and they all have the same sound effect.
Yes.
And it's not. It doesn't mean the game's going to be terrible, but I'm tired of that sound. I'm not going to lie. That is absolutely the case. So anyway, so there is a kind of backstory here. So we need to stop the invasion. Some evil guys, magic orb, the usual thing. Spirit animal. Okay. And so now the music's nice enough, but I am going to turn it off because I can't really talk over the game at the same time as the music. So I am gonna.
It's a nice little Irish ditty, though.
Yes, hello Mitsuyama. It is. It's nice. It is. You can't turn the music off though, right?
No,
and
not that I know.
I've got to say. I mean, I don't know how it works with with MPAGD. This is made with that multi-platform, MPAGD, if you like. Anyway, I don't know how it works with that, but on an AGDX, you can check a key and press music, choose music 0, and it'll turn the music off. And I think that's the same because that's what I suggested to David for Musicizer, and Musicizer is I'm pretty sure what's used for this. So
yeah,
I think it's all David's code underneath. Right. So yes, if you're going to make a game, please, no matter how much you like the music, it doesn't necessarily mean other people like the music. Not only that, but they may be playing it, on the go or somewhere that other people can hear, and they don't want. They might just want sound effects, and they can live with that, but the music might be irritating. I don't know. But either way, it should be always be the choice of the player that they can turn the music off. In my opinion, right? So, of course, on an emulator, I could probably just disable the AY chip, and then I'd be left with that wonderful AGD sounds that I love so much as well. So anyway, now look, none of that reflects badly on this game, right? So yeah, keys these, you just have to press the fire button a few times, and then you'll get it right. Okay, so this is an interesting game. What are your first impressions of these graphics, Andy?
I really like it. I think it's got a really interesting art style. Some of it is quite reminiscent of like Nixie as well, so it's kind of in my wheelhouse. I really like it. I like his use of like the black for like the background, like we see here at the top of that screen. He uses that quite a lot throughout the game, and also nice little reflections in the water at the bottom there.
Yes.
Overall,
I don't know many games that use a blue paper and a black ink for the game.
No.
And it does.
No, I don't.
And it does actually come out quite nice. 80-90% of games they're on black, aren't they?
Yeah.
I know with Snowed Under we did a blue background, but we still used white. Chez Maxime also used a blue background, but then it was white. I was following a red, white, and blue style for the French flag in that situation. But nevertheless, but the black actually works really well. It stands out. It's clear.
Yeah.
And it gives that. It feels atmospheric. It feels like it's at night time, doesn't it? It feels.
It does. Way. Yeah.
And as you said, nice. he uses a foreground and a background effect quite well too, with those sort of towers in the background and so on. So we like this. We like that visual style, and as you said, a little bit like Nixie. A little bit like Bruce Lee as well, I was going to say. This game does actually remind me a little bit of Bruce Lee. I'm not saying that it's like Bruce Lee, but it has the two things about it that is similar to Bruce Lee, in the sense that there is a sort of adventure storyline there, right? But then there's also, like, you have to solve puzzles in order to progress, right?
Yes.
So, of course, it doesn't have combat like in Bruce Lee, but Bruce Lee has a certain amount of puzzles where you have to collect lamps and things. It's not exactly, it's not exactly intellectually challenging, but nevertheless, what this game does surprisingly well is it combines a puzzle game, like a screen-by-screen puzzle game, with an adventure kind of story, right?
Yeah.
To the extent where you and those two things do flow. They do flow quite well together, in the sense that the story progresses as the difficulty of the puzzles progresses in quite a nice way.
Yeah. And you, as you go through the game, you learn that you have to do certain things in order
Yeah.
to progress.
Yeah.
So it's not just a single layer of
Yeah.
problem solving at
Well,
times.
listen, here I am, Andy, on the screen one. Why don't you talk me through? Tell me a little bit more about this, about how this thing kind of works. Because I'm stuck right now, and I can't. I'm trying to move.
You're stuck in the cage, and obviously you need to get out of there somehow. And we can see over on the right hand side there's a switch on the wall. So one of the ability, or your main ability in this game, is that you can call your spirit animal. In
Yes.
in this case, it's a goat.
Yes.
And he's not particularly happy about his spirit animal being a goat.
He doesn't. And there is that wonderful use of the F word by a non-native speaker.
Yes.
Where they imagine that it can be used in the same way as the translate. It's really interesting, because when you translate things from one language to another, the level of vulgarity doesn't translate in the same way, right? Like there are words in Russian, right, which that if you translate them directly, they sound, to us they would sound really rude,
Right.
And yet they're just fairly everyday in some ways, I mean, another example is in French. The word in French, con, right? I mean, it can be used in all kinds of ways to just mean an idiot, like a dickhead or something like this,
Right.
And yet it also more or less could translate as the C word.
Okay.
So, which you certainly wouldn't use at that level, right?
Yeah.
It's a word of last resort, isn't it? Really, in English, but it's not a word of last resort in French. No. And so I suspect that might be similar in Spanish. And the translation is this. I mean, I would say that you might use a word like, I don't know, gadzooks or something, right?
Yeah.
Are you familiar with that word? Isn't that Timothy Claypool? Wasn't it Timothy Claypool from Rent a Ghost or something?
Rent a Ghost. Yeah. Now we're showing our age.
Yeah. Well, something like that, right? Gadzooks or some old. That's a kind of phrase that a jester would say. I'm just, again, it's not spoiling the game, but if you want to get that sort of in English, that's probably what you would say. I don't know if you have another suggestion. Yeah, but I would say.
Yeah, I probably would have just put a goat. Why?
I see. Well, I know there is definitely there's definitely some humour to be had there.
Definitely. I mean, that's why I think that's why it's shock, isn't it? Yes. Shock humour.
I'd vote for gadzooks. Although, I mean, I don't know the origin of that word.
No.
It's not a word that I have ever used. I mean, as in personally. Like if I'm watching football and there's a penalty, I don't go gadzooks, right? Or something like this. But it is apparently gadzooks is archaic exclamation of surprise or annoyance.
Okay.
Yeah, circa 1652, possibly from the words God's hooks, the nail of the crucifixion.
Okay. Good.
Anyway, gadzooks is a good word. And there we go. And as you can see, guys, this is not your average kind of review. We are going to be somewhat tangential here.
We throw in some culture as well.
We do try. So anyway.
So now.
Yeah. So he's got a spirit. Okay. Now this is your typical video game with two characters, and each character has different skills.
Yes. But we get to my first little annoyance.
Okay.
Which is
move
the goat, Alan.
Okay, just a minute. Now, those of you that know Andy John's games will know that they have a lot of animation in them. And animation frames is something that Andy is very passionate about. And he will gladly sacrifice 2 or 3 levels in his game in order to have a few extra frames of animation. And we often have discussions at length about this, and his assessment of the number of frames is a little bit different to mine. But nevertheless, we do have a goat here, and what you can do, you can switch between them, right? So now I can switch between the goat. Now, I think personally, when you're switching between this goat, we talked about this, it's kind of, I kind of feel like it should have some transition where something moves between the player and the goat, or the goat and the player, just something like a spirit, or you know what I mean? Rather than just having them both go like this. But I suspect that is, again, memory related. But if you look in the top, in the middle there, guys, you can see which one you're controlling. So there, that's controlling the goat. And as you can see, I mean, I don't know. I personally think that that animation isn't too bad at all, really. I mean, it's okay. It could.
The transfer?
No,
that's not bad.
No, the walking the goat. Look, it's not that bad.
Oh, I don't know.
It could be better, right? It could be better, but then I mean, memory, isn't it? It's all memory.
Yeah, but it's one. Excuse me. One more frame of animation per direction, I think, would make all the difference there.
Yeah, and look, when you've got the sort of goat headbutting, it does just fly along.
Yeah.
But I really do suspect that that's more to do with memory restrictions than anything else. But anyway, yeah, we would like. I suppose, you know, in an ideal world, Mitsuyama says it looks a bit slidey. Yes, it is a bit slidey, isn't it? That's true. I agree.
Yeah.
Yeah, and you know, that's. We are being picky, but that's what we're here to be, right? We're here to be a little bit picky. Yep. And as I said from the beginning, we do really like this game a lot. And yeah, so that's that, right? And now obviously what we need to do is we need to get this poor jester and rescue him and get him out of his cage, right?
We do.
So I think we can just jump up and hit this rather phallic looking switch.
Yes, it does look a bit suspicious.
And yeah, the goat has caused the switch to be deflated, let's say, and we can now control the player. We can switch between them, right? There we go. I can switch, and now I can be this guy, like this, and then look what happens when you hit the goat, right? You will basically get thrown up into the air. And there is the first and main mechanic of this game, right?
Yes. Yes, this is what you do on pretty much every screen.
Right, but we can't... I mean, you can actually jump. The player can actually jump, can't they? I think they can.
He can, yeah.
Yeah, look, you can jump. But you can't jump anywhere near as much as you can when you get hit by the goat. So presumably what we do in the first game is we switch to the goat, and then we sort of jump up and give him a headbutt like this, and then switch over again, right? So, and then I should be able to just jump like that, right? There we go, that's good.
Yep.
And then I can just kind of make that jump there, yes, and then I hit the switch, and then the switch is open, right? And then there we go, we're in the next room, right? Okay, so that's kind of how that works. And then once you've gone in the room, you get your ball back, the ball that contains the goat, and then you can throw that ball, and then the goat can reappear, right? And what we want to do is there's that little purple thing below me. That's some kind of a talisman. Is that right?
It's a collectible of some sort. I'm not entirely sure currently what that does.
I think, is it not like where you collect them and then you there's a shop and you can trade them in or something?
Oh yes, sorry. Yeah, you're right. That is one of those. Yeah, there's a few things that you have to collect
Yeah.
as you go through the game. I
So
think I found two or three things.
what we would say immediately then about this is that, you know, I'm always saying that, oh, it's another game where you wander around and you collect stuff and you whatever, right?
Yeah,
And this is quite a nice way around it, where you've got a full kind of a map, and there's a story, and there's a whole area to explore, and I think there are some items to collect and so on, but you have two different kind of characters to control, and you have to solve the puzzles in order to make the progress, right? So um, I need to now look at, what do? I fire this goat out, right? And then switch to the goat, but I can't jump there, so oh, I get it. So in this example, as far as I remember, am I correct to say that when the goat does the butt, he can jump really far, right?
yeah, you can as long as you hold it
So yeah,
down
the goat
with
can
the
jump,
direction.
but rather than throw a ball, the goat can actually do this kind of headbutty thing, and you can run quickly and jump with that. I think like that, right?
Yeah,
There you go, and then you can break open the crate, which the jester can't. Right, so we can go back over there like this. Presumably, what we want to do. Well, so he can go down here now and get this, right?
yeah,
But he's never going to get. He won't be able to jump that without the goat's help. Am I correct? I think so.
you're correct. Yeah,
Right. So we need to jump that one back over here, and then I guess put the goat on the edge of there, and then I guess we need to just go like this, and then we'll get over there, switch back to the goat again, and then whoops, jump across, and then hit him, and then he'll hit that platform, and then we'll go back, and then we'll go up and onto the platform, and then through. There you go. Okay, so that's nice. That's the general idea, and we do like this game overall, don't we?
we certainly
As I
do.
said, and let's
So here's another nice example of the background, because you've obviously got the city with all the lights. It's
yes,
it's just really nice the way it's done it. It's so
yes, but at the same time, Andy, you weren't so crazy about those monsters. I mean, they do look nice in terms of
yeah,
they look quite sinister,
yeah.
but
We
they
talked about this
are
for a
they
bit,
are
didn't we?
they're very mechanical, aren't they?
Yeah,
Right.
yeah.
So
We would have liked some inertia, and I guess if you had, obviously you've got a patch for AGDX, which I don't think they can use in MPAGD. But it would be nice if they jumped up, with some inertia, flipped horizontally, sorry, flipped vertically, and then dropped back down into the water.
yeah, yeah,
And you
yeah.
know me, I would even have a splash when they went back into the water. Um,
Yes. Well,
but yeah,
I might do
I
a
think the movement is just a little
I
bit.
might do a sort of pixel effect or something like that. But interestingly enough, though, I mean, I don't know if this would work or not. I might be able to. Remember, I said I had this kind of um, tile tile grabber thing.
Yeah,
I might have a look and see about if maybe because what I could do potentially, right, is I could grab this screen and then I could put it um, into AGD, right, and then
yeah,
recreate the whole screen quickly and easily,
yeah,
and then well, potentially, I don't know. Yeah, mind you, then you'd have to do something with those graphics as well. Perhaps we'll do it another time. We'll do it off camera because I think it might be a bit too fiddly.
yeah.
Let me just check what's going on in the chat. Says, yeah, you can tell games with majors and emotion engine for the latter. It tends to be players slidiness gives it away. Never really. Yeah. Well, I like a bit of, I like things to feel a bit analog. I think the player, we mentioned it in Snowed Under, I mean, it was because it was kind of icy world that he does slide a little bit.
Mm.
And that's really, in the what the kind of conclusion that we came to really with this game is that it is really, really good, right? As
Yeah,
far as games written with AGD or MPAGD are concerned, this is definitely kind of at the top end, isn't it?
it's at the top, definitely.
Um, and this guy he doesn't want to, this author, Angel, he doesn't want to just create another fetch quest, you know?
Yeah, he's put a lot of thought into every
Yeah.
single level.
Which is, when I call it, and I say this game is a bit naff, NAFF, so NAFF, right? Which for me stands for not another fucking fetch quest. Anyway, um, yeah. Anyway, there's nothing wrong with the fetch quest if it's kind of interesting, it has a bit of a narrative and so on. I don't know, but yeah, he's done that really well, and I think hats off. Really, I would say
Yes.
we like it a lot. In fact, pretty much every criticism that I could direct towards this game is related to the limitations of this game engine, not to the coder themselves.
Yeah,
Right?
I go along with that.
I mean, you've got we know the sprite engine is very memory hungry. We
Yeah,
know that the sound engine is very, very one dimensional. Let's put it that way.
yeah,
Not that the Spectrum beeper is exactly, the it's not exactly a SID chip, is it? But there are ways there are ways around that, and it would be
yeah,
nice to see that. There's a certain limit. There's a certain point where you just, as a one-off. I mean, as a one-off, those sounds are kind of okay. It's just when you've heard them in every single game, it just becomes a little bit
well, that's it. Yeah,
too
there
much.
are no options for it, are there? It's
Yeah,
just how long you want that sound to last.
more more or less. Yeah, that's kind of, yeah. You can do some things with loops and things like this actually, but
Mm.
yeah, they're not. They're more or less. It doesn't do much. Um, yeah, what we would like to see in this game is a little bit more, like these two fish. It'd be nice if, because they just look like a gate. It just looks like a gate going up and
Yeah,
down. They don't really look alive. They look quite robotic. And I think um, if you had something where um, they were a little bit more animated, like, they jumped up and then
yeah,
they turned and then they dropped down again. Little splash, maybe some bubbles or something just before they jump out or something.
yeah,
Just to give you a feeling of that, yeah. And the same. I mean, the waterfall on the left hand side there. That's using Flash, and you know what I mean. It's a kind of a clever thing to do, but at the same time, it doesn't really do the game justice, does it? I mean, what do you think?
yeah,
It's not bad though. It's a pretty good illusion,
yeah,
but um, yeah, a few little things like
yeah.
this. But this is, I'm really being kind of critical
We're
here.
being picky.
Yeah, we are
Yeah,
being a bit picky, which is what we're here to do. We're here to be a bit picky and say that, look, this is what I would do here, here, and here. But it's like we said, if you want to really push the game just that little bit higher, then those are the kind of things that you need to be doing. And then also, if that's the case, then you need to you probably need to move beyond this kind of cookie cutter engine, which is always
yeah,
going to have those limitations, right? But I don't think you can underestimate that little bit of extra character, right?
mhm, Yeah, definitely.
You know, I mean, it's easy. It would be easy for me to sort of say this about Chez Maxime, but I guess I could just bring it up and just to demonstrate some of that kind of thing that I think is important in terms of detail. So,
Yeah.
I apparently can't play my own game because I'm not logged into itch.io here.
Yeah.
Do you have a copy of it there? You can just send it to me on Facebook. I'm not on the same laptop, you see. So, but I would just mention a few, little details. Why not? Just to.
Mm. Oh. No, I don't have. Oh, well, I've got it on the other laptop.
Thing is, I don't know why won't it let me just. I should be able to just log in, really. Oy. So hot. Hope you're all doing well, guys. Hope you're enjoying. Let me know if you like. We'll continue with these kind of reviews where we look at a game like this and talk about it in that sort of level. Yeah, I should be able to just.
I can't find it.
Well, we'll see if I can. It's okay. I'm logged in now.
Yeah. Okay.
Yeah. I just wasn't sure if I would remember. Yeah, I should be able to just download my own game from here. Yeah, so with Chez Maxime, I really was pushing for this kind of let's go absolutely kind of mental with the extra details and within the game, right? So, what? There's a lot of little details. So you've got the little animated candles. You've got the little bug zapper down here. You've got the little Chez Maxime screen here, which is also, it's actually slightly random so that it looks like it's slightly broken, giving it that kind of a little bit of cheapness.
Oh yeah.
To the effect of it, so that it just looks like a neon sign that isn't really working all that well.
How did you do that?
It's just bright.
Oh, is it?
Yeah, I just have a bright and a non-bright, and then I just added it. And the chef basically cooks a dinner, and then he has a little cigarette break, while he's waiting, and then various other things start happening when you start serving the food. Later on he kind of starts throwing the food across the table. And that was another thing, actually. You see these little speech bubbles. I was thinking about that with this Buffonada game. The text menus and stuff.
Yes.
Yeah, I think they probably would have benefited from something like that, right? It's like some kind of dialogue boxes.
Yeah.
rather than just printing across the screen. You know, it just gives something more personal.
Yeah, the guy that's making that like dungeon crawler type game, like the Gauntlet clone,
Mm.
he's done something similar. He's used like some of the character set to make like a scroll for his, which I think I did something similar for Nixie too.
Right.
Um, yeah, and it does add quite a bit to it.
Yeah. I don't know if you noticed this, but the platforms, the flooring on the of the game,
Yeah.
of the it's a little nod to Super Mario Brothers 3 on the NES. I don't know if you
Oh, is it?
pick up on that, but yeah, it's just a little. It uses a similar effect if you look at the game. Yeah, I put little nods in to various things within the games, you know. But that chef, by the way, is also quite a nice trick where you've got a sprite there, which is just um, it's just the chef doesn't have a head in the sprite. You can see when he's carrying the
Hmm.
you see how he carries the big dish.
Yeah.
It's like we just basically took the so rather than overlap, because you know AGD doesn't like sprites that overlap.
Yeah.
So what we did is we just cut his
Took it
face.
away.
We just cut his face off and put
Yeah. Works well.
yeah. And one nice thing about it was that the we really wanted to have all different foods for the people, but it was going to be lots of sprites.
Yep.
You know, you imagine carrying the food around. But then when we come up with this idea of this great big tray, this kind of great big dish with a tray with a bowl over it,
Yeah.
it means that it's always the same until it arrives, and then when it arrives, it's an object. You see, then it's not a sprite, so it saves
Gotcha.
memory.
Yeah.
But again, it's that kind of funny thing where you've got this real sort of pretentious idea that because they're serving burgers and chips, but they're so pretentious that they want to serve them under this massive sort of sophisticated tray, something. Anyway, so yeah, well, I wanted to just make a few points there about ways that you want to give character to a game.
Yeah.
But you're always limited, aren't you? You're always limited with memory
yeah.
on one level or another. So yeah,
It's nice. It's a very
anyway.
simple concept, but it's executed very well.
Yes, thank you, Keys Z's there. We'll put a lot of time in. I mean, it's Gabriele Amore, who's a great pixel artist, and he really puts a lot of life into the characters, and you know, you couldn't do a game like that. Most of the animations there are two frame, and that's obviously anathema to Andy, but there's lots of them and they look really good and they work really well, so it kind of yes, Ro, it does, it's just more professional. It just feels like that's what they would do in an arcade, right? That's how you want to.
Yeah.
I mean, it was an interesting situation because it was such a simple game where you think, well, I've got all this memory, let's have a lot of fun with it, let's really push that, right? You know, I suppose that's the luxury of that. It's not like he's exploring a whole massive maze and trying to you know, where you're using up the memory for that. Anyway, so yeah, good. Let's switch over, because I mean, you know, we did a sort of 2.5 hour stream last time, and that was a little bit too much. I'm gonna try and keep them down to a couple of hours. We had a nice chat there about games and gaming, and we have actually gone into double figures today, which is nice. I think we've dropped down again now, but nevertheless, the regulars are all here, and that's good to see. So let's go into our coding session. Let's go back to that. You all set to do a bit of maths, do a bit of code?
I am.
I'm wondering why it is is it gonna turn up? Is it turning up? It has turned up. There it is. We're all set. We're looking good. Okay. So let's review what we had last time. So we basically now you know how to do a basic loop, right?
Yeah.
You know how to copy data from one part of memory onto the screen.
Yep.
And we even did a little bit of animation, didn't we? So
We did.
yeah. So let's do something else then. What else did we do? We did one more thing. What was the last thing that we did? Was it jump or?
We did. Yeah, we did a jump to make two tiles, didn't we?
Yeah, something like that.
And then I messed around and changed some attribute colors.
Oh, I see. Yeah, right. That was off camera, off stream,
Yeah.
so to speak. Yeah. What I've actually done here is I set a little challenge for you here, because this actually prints the letter A, and then it prints the letter B, doesn't it?
Oh, yeah.
And
I didn't
that's
get.
right. Okay. So what we're gonna do is we're gonna do Hello World, right? Aren't we? That's what we said we were gonna do. Right. Okay. So Hello World at the top of the screen seems like it shouldn't be a massive challenge, but let's see how we go. We'll see what comes up, and then whatever comes up we'll talk about. So I'm gonna sort of reduce this back to what it was before, right? So
Yeah, I've messed around with it as well.
don't worry, that's fine. We'll start from what we're gonna do is I'm gonna create a separate. We're gonna get rid of this, right?
Okay.
And we're gonna. Oh, just a moment. I mean, if the stream is fast enough, but I'll share it with you on Discord so you keep up on the stream if you prefer, right? Is that preferable, or do you?
Yeah.
Are you happy enough with it on the stream?
It doesn't seem to be that bad at the minute. So
Yeah.
I'm just gonna copy it and make a new file. So.
Okay. So what?
Yeah.
I'll tell you what we're going to have to do before we do Hello World. Right. We're going to have to talk about a little bit of multiplication, not just addition, but also multiplication. Right.
Okay.
So you can see here that we've got font start 3C00, right? You see that? Did I share it on Discord? I can't remember.
I got it. Yeah.
Ah, no, you're here, right? Just give me a second. I pressed screen share, but I didn't tell it which screen to share. Okay, we're all good?
Yes.
Everyone all set for some Z80 assembly language learning? Here we go. So, again, if this is the first time, guys, which there might be the odd one of you that is, then there's a small series on my YouTube channel. Happy Coding ZX is also that's what it is on YouTube, called Introduction to Z80, and it goes through some basic principles, and you should watch that really before you watch the streams. And obviously there are 3 or 4 streams before this, and there are some principles there that we'll be working on. Okay, so let's talk about how we would print a font. Yeah. Now I'm
Yeah.
gonna keep this fairly simple, right? In the sense that I'm only gonna use. Let me see if I can get. Let me bring something up here first of all, if I can find it. Just a second. Just hope I have it here. Okay, just bear with me.
Mm-hmm.
Okay, so within the ROM, we've got a font, right?
Yeah.
Which is basically bitmap data. You understand what I mean by that, right?
Mm-hmm.
It's just it's pixel data.
Yeah.
So if you imagine, I tell you what, let me open ZX Paintbrush. That's probably going to be an easier thing to do. I was hoping. Can you send me anything at all which has got AGD engine in it? I think. Oh, just a minute. I've got it here. No. Oh, I thought I had something. Can you send me anything with that you're working on in AGD? Whatever. It doesn't matter. I just want to get the font. I just want to get the font so that I can
Yeah.
so that we can put it up on screen here for people to follow. Okay. You sent me it on Facebook or something?
Because I'm on the laptop that doesn't have anything.
Oh,
One sec. I'll send it to you now.
I could probably download it from my own. I could probably download it from my own itch actually. Yeah, I think I can just download it from here. Right, has that worked? Yes.
But teal.
Okay, so what I'm going to do, just so that we have something to work with, is I'm going to save a screenshot of. The reason I've loaded it into AGDX is just because I can save off the pixel data of the ROM font there, right?
Right.
And then we can. So essentially, right, at the address. Just bear with me, right? I need to make sure that everyone can see what's happening. Okay, so you can see that there, and now let me open ZX Paintbrush, and hopefully now I can load that in. Yeah, that's good. Right, okay, and we'll just lose this, and lose this. and let me just check. Where is ZX Paintbrush? Here it is. Right, I'll bring it up here. I'm just going to put you down there a little bit, Andy, just, if you don't mind. You're not on screen there for some reason. I don't know why, but
No, I don't know why.
not to worry. Okay, so if you're looking at what we're looking at here is the graphic data that's stored in the Spectrum ROM, right?
Yeah.
In this particular case, and there's a special system variable which tells the Spectrum where it can find that font, right?
Okay.
That's why when you do a poke, you can change the, you can point it to a different part of memory, and you'll get a different font.
Right.
If you're using ROM routines or whatever, I mean, you don't have to. You can do everything yourself if you want. It's generally what I prefer to do. But as you can see here, right? If you're familiar with ASCII, this is laid out in ASCII order, right?
Right.
And the space, do you know the ASCII character for space? The ASCII code for space?
Isn't it 32 or something?
Yeah, it is. It's 32. And the ASCII character for capital A?
65.
Right. And so you can see here, this is 32, this is 64. Yeah. And this is 96, and so 97.
Yeah.
A would be that one, right? So you can see what the codes are. Yeah. So when you want to, if you start off in memory, right, you remember the address? I'll tell you the address. It was at 3C00 in ROM, right?
Yeah.
And that is going to be here, right? Means character 0 is going to be there, right? And character 32, that's the space there, and character 33, that's the exclamation mark, right?
Okay, we've got a serious lag on Twitch.
I see. All right, just a second.
But yeah.
I think it.
So basically, space is the first thing in the.
Just a minute.
In memory.
Well, no, because you've got you've actually got just a second, right? Just to be clear on this, right? Okay, so I'm going live with ZX Paintbrush now, just for you temporarily. The stream can hopefully see it. Okay. So, no, what you want to do, you see, you want to match up the ASCII with the graphics, right? So, this is 32. This is 33, 34. So you've actually got 0 to 31 here, right?
Oh, okay. Sorry, I didn't notice.
See what I mean?
I thought you just grabbed more than.
You're not going to be using those, right?
Yeah.
Because those are like system codes and different things like this, So
okay.
You don't use them. So it starts at 32. But what it means is that if you start from this address here, and you want to print character 65 there, yeah?
Yeah.
Then you've got to go down 65 characters, yeah? So logically enough, right? Okay. Now, the thing is that each of those characters, as we know already, uses 8.
Yeah.
It uses 8 bytes, right?
Mhm.
And so that means that all the way across there is 32 characters, and each one of those are 8 bytes. That's 256 bytes, isn't it?
Yes.
And so that's also 256 bytes as well.
Yep.
And so that means 512 bytes, and then another 2, I guess. So with the calculator, if you work that out, if you work out 65 times 8, you'll see it's 520, right?
Yeah.
So it's 512 plus 8. Yeah?
Okay, yeah.
So it's the start address of the font. Yeah? So
Mm-hmm.
if you want to know the graphical address of any character, it will be the start address of the font plus
Yeah.
the ASCII code multiplied by 8.
Okay, yeah, makes
Clear?
sense.
Clear?
Yeah.
Yeah?
Yeah.
Now, if we're going to do something like hello world, right?
Yeah.
Then obviously we're going to read a message, and we're going to read the ASCII code, and then from that ASCII code we've got to calculate the font
Okay.
address,
Yeah.
right?
Yeah.
Now
Yeah.
to do that, that means we're going to be multiplying a number by 8 that's going to be bigger than 256,
Yes.
right? And then we're going to be adding it to a number which is also going to be bigger than 256. But there is another way. There is another way that we're going to do that today, just to keep it simple, right?
Okay. Yeah.
If we limit ourselves to only this row, right?
Okay.
Then we are within 256. We only use 256 bytes.
Right.
Yeah, clear?
Yeah. Yeah.
So instead of starting from instead of taking off instead of instead of adding the ASCII code of 65, right?
Yeah.
We'll take 64 off the ASCII code, and then this one will be 1, and this one will be 2, 3, 4, 5. You see what I mean?
No.
Okay, look, I'll just repeat myself, no problem. This is the first 64 characters, correct?
Yes.
Okay. So, and this character is character 65.
Yes.
Right. But what we want to do is we only want to use this row.
Yeah.
Okay, so we'll give these, and so instead of calling this one 65, 66, and so on, we'll just call them 0, 1, 2, 3, all the way up to 31, right?
Yeah. No, I get that.
Got that, right?
Yeah.
So, therefore, if we're given the ASCII code of 65, yeah, we know that our font code will be 65 less 64, which is 1.
Okay.
You see what I mean?
Yeah.
So this is ASCII code 65. But
Yeah.
we're not, because that's what it will be. That's how the code will read the letters, right?
Okay. Yeah.
So what we'll do is when we read the letters, we'll take 64 away, and then we'll multiply by 8, and that would give us any character within this line. Do you see what I mean?
Yeah, I think so. I need to see it in action, but yeah, I think I get it. Yeah.
Okay. Well, look, I can more or less demonstrate it really. So, okay. So let me move off of. The reason I'm doing this is because you understand 8-bit, and we know a certain number of we only know a certain number of commands, so we'll be able to do it this way without it getting too messy, right?
Okay.
Okay. So and I'll explain it in very simple terms. We've got font start here, right? And it's 3C00.
Oh, I can only see ZX Paintbrush still.
Okay. Yeah. Thank you for reminding me. I've got to unshare that one for you. Right, let's disconnect that one. How are we doing in the stream? Everybody's good? You guys following along all right? Just ask questions if you do need to. All right, so. Okay. Yeah, I'll explain it again now, and it should be clear enough. Let me just share. Oh, God, can't seem to find you now. Are you still there, Andy? Sorry, I lost you for a minute, didn't I?
Yeah.
No, that was my fault for sure. Don't worry. Press the wrong button. Okay, we are back, right? All good?
Yeah.
Okay, so let's do something. I tell you what. Let's make this a little more interesting, right? I'm actually gonna go back to ZX Paintbrush because I think this. I've just realised it's probably the easiest way to do it, right? Because we'll actually see the physical manifestation of the data, and that's always good, right? Visually, that's always good, right? So let's do that. Well, look, if you can see, can you see ZX Paintbrush in the stream? Guys, can you see it?
It's
No?
behind a whole load of other stuff.
Right. Okay. There it is. Okay. All right. So I tell you what I'm going to do, guys. I am going to save this off. I'm going to export this as data, right? And that way we'll have literally a copy of the whole font. Within our source code, and that'll make it easier, right? So just give me a second. So what I'm doing, you remember when we copied that font the other time, when we copied the characters?
Yeah.
And we did 8x8 blocks, and we set them as,
Yeah.
I think we set it as binary. Well, I'm going to set it as hexadecimal output this time, rather than binary. And we'll put bytes per line. We'll put as 32. Yeah, I guess that should work. Okay, right. So it's going to be quite a lot of data. So let's just take a look at that. Oh no, what have I done? Have I moved the wrong bloody thing? Okay, we're back there. Yeah, that's good. Okay. So this is the data.
Right. Yeah.
Okay. Now if you look closely, you'll see, well, this one, the first one, that's space.
Mhm.
Yeah, each of these is 8. 1, 2, 3.
Yeah.
So that's space, right?
Yeah.
And then this one is exclamation mark, right?
Yeah. Yeah.
And so on.
Yeah.
So let me separate. I'm going to separate them up into something like this: 1, 2, 3, 4, 5, 6, 7.
So could we not have just increased the address of font start so that it starts on that line?
Well, yes,
with
but
the
then,
capital letters.
Well, yeah. Now you get into what I was going to do, but then you won't. It won't align with the ASCII code. Then you see. But I'll explain it. Don't worry, I'll explain
Okay.
it. So it'll be clear enough, right? So what we've got here. I think that should be 8. Is that? Let me see. Is that 16? Yeah, that's 16. And so that should be 16, and let That should be 16.
Yeah.
Okay, I've broken them up into 16, and so we know therefore that this one that one is space and that one is exclamation mark, right? As we said, and then once we get to here, then this one here should be the letter A, I believe, right?
Yes.
Capital A. And this one would be, well, this one would be, ASCII 64, and this one would be ASCII 65.
Yeah.
Right? And we're actually, this one is ASCII 32.
Mm-hmm.
But notice then that there are in each one is 8 bytes. Yeah?
Yeah. Yeah.
Okay. So let's take a look. This much is clear, and it should be fairly workable. And I'll just call it font, right? In fact, what we'll do is we'll take away font start, because we're not going to use the ROM now, right? And instead we've basically replicated that part of the ROM into our source code, right? That's the reason I've done it. It's all educational purposes. Then we can see. In fact, look, if you like, you remember font start was, what was it? It was 3C00, right?
Yeah.
And obviously this is the third. This is one row down. So this would be in ROM. This would be 3D00, wouldn't it? Right.
Right.
You understand?
Why? Sorry.
Okay, because it's starting from character 32, not from character 0.
Oh, not from. Yeah. Okay. Yeah. Sorry. Yeah. Yeah.
So look, if I go down to 3C, let's go to 3D00, right? In Spectaculator. Can you see that in the? I don't know if you can see that in the debugger. Well, if you look at it yourself in memory, if you looked at the actual screen memory, then you would see that it's I've basically replicated it. It's the same as you would find in I'm just going there now, so you can see, for example, at 3DOB, I can see it says 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 24, 24, right? So it's exactly the same. Is that clear? That we've replicated the ROM font into our source code, yeah?
Yeah. Yeah.
Okay. So let's take a look at what happens when we assemble it, yeah? So what you can see here is we've got a little bit of code, right? And then we've got the font, and it's starting here at address C00D. Right?
Yep.
Which is not, which obviously that's not ideal, because it's not aligned, is it? Right?
Mm.
So what you do is I'll put this in here like this: align 256, right? And watch what happens to the code when I do that. Now, do you see? Look where the font is starting now. C100, right?
Yeah.
And notice then, if I'll just break this up, you can see that font, the next one starts at C108.
Yeah.
And then the next one at C110. And then the next one at C11. Do you see what I mean? So each one, you've got the addresses of the font are then going to be 08 in hex 10, 18, 20, 2. You see what I mean?
Yeah, I'm not really following.
Okay. Each character is 8 bytes long. right?
Yeah, that I get.
Okay.
I just don't.
Now
I don't get.
I've stored them in memory exactly
Yeah.
on a line of 0 on the low byte, yeah. So that they're lined up in the memory, to
Right.
be easily addressable, right?
Okay. Yeah.
You see what I mean?
I think so.
So it's kind of like, let me try and think of a comparison or something simple like that. Imagine that you've got a grid, right?
Mhm.
And in each grid, within each grid, you've got 8 squares, well, 8 by 8, right? So it's 64
Mhm.
squares, right? Now, if you line up your data so that they line up with those squares, then it's going to be really easy for you to read the letters. But if you don't line them up, there'll be an overlap, right? It's a bit like,
Yeah.
like when you load a
Yeah.
font in the wrong place.
Yeah. Yeah. And you get half a character in each square. Yeah.
Yeah, right. So that's what I'm doing. I don't want to have half and half here and there, because it just makes calculations difficult,
Okay.
right? So what I mean by that is you can see you can see where these are stored in memory, can't you, right? The first one is stored at C100, right? And there are 8 bytes.
Yeah.
Yeah? That is space there. You see it?
Yeah.
I mean, ignore that. It's just that's what that is there, right?
Yeah. Why is it putting that interim one in there?
What, the C104?
Yeah.
Oh, because it just shows 4 bytes per line, you see?
Oh, okay. Sorry. Gotcha.
You see
Right. That
there?
was slightly confusing me.
Yeah,
Yeah.
it's just, yeah, it's telling you, look, the top half of
Gotcha.
space and the bottom half of space,
Half.
that's there.
Okay.
And
Fair. Yeah.
there's my
Okay.
8
I get it.
bytes, right? And
Yeah. Yeah.
here's my 8 bytes there. Yeah, I see why
Yeah.
that would be a bit confusing. There's my 8 bytes for that one, and there's my 8 bytes
Yeah.
for that one, right?
Yep.
Okay.
Cool.
And so what you'll see, because I've aligned it there, it means that that one's at 0, and this one is at 8, and this one is at 10, and this one's at 1, 8, and this one is at 20. So it's all lined up nicely, right?
Yeah.
And because there are 32 of them, and it's 256 bytes, then you can see here, look where 64 starts. It starts at C200, right?
Yeah.
So the first 32 characters are at C1. The second
Yeah.
32 characters are at C2. And the third set are at C3. See what I mean?
Okay. Yeah. Yeah.
And Mitsuyama says align is an assembler command, not a Z8 instruction. Yes, correct. It's telling the assembler to to skip anything. So for example, it's at C00D here, right? And it basically means go to the next point of memory that is aligned to 256, right? Which basically means the low byte is 0.
Yeah. Okay.
All right. So when you say send me the file, oh, you mean the font? Yeah, I can do that. Yeah, sure. Okay. Okay, so this is a really important lesson in terms of assembly coding, right? Which is that if you have the memory to do it, yeah, then you should align your data, because then most of it can be addressed using only 8-bit notation instead of 16.
Gotcha.
Right?
Yeah.
Now, just give me a second. Let me see if I can send this to you. All right. I mean, I don't know if this. Oh, your message is too long. Okay, just a second. I don't know if this will work. The quickest thing for me to do is paste. I'll just paste it to you in Facebook as a message. It's a load of data. That's the thing you need, right? Just the data, right?
Yeah.
Right, you should be able to catch up then while I do this, because I've got to remember I'm live. Okay, so important lesson. If you align your data, because it's all about addressing, right? Everything in memory. It's data and it's addresses. Yeah, that's everything. So if you align your data to the 256 byte line, right? Then you can use 8-bit. You can use more or less use 8-bit addressing, because you know, for example, that space is always at 0. I mean, yes, it's C1, but it's at 0, right?
Right.
And what's important here is I don't need to use all of this font data. Yeah?
Yeah.
I only need to use perhaps the capital letters. For the purposes of this demo, I only need to use capital letters, right? So this is why now you'll see this is why byte alignment is going to be really important. So I'm actually going to get rid of all.
You need 32, don't you?
Yeah, let's say we'll work with 32 because that's 256 bytes. That's going to be easy. Yeah, it's the simplest way of working with it, right? So I'm going to cut that off there, and I'm going to put this to here, right? And then that's there, and then we're going to get rid of this one as well, because we don't need it. That's lowercase. Yeah.
Okay.
Perhaps we'll do that another time. But we'll get rid of it for now. So there, 1, 2, 3, 4, 5, 6, 7, 8. It's 32 characters. Yeah.
Mm-hmm.
Each one of those characters is 8 bytes. Got it?
Yeah.
32 times 8 is 256. Yeah?
Yeah.
Now, if we look at the memory layout, you'll see our first character is stored at C100, right?
Yeah. Yeah.
And our last character is stored at C1FC. Sorry, C1F8. Yes?
Yeah.
Which means we don't need to change the high byte, you see?
Yeah.
For any character within that range. And the reason that works is because it's aligned, and it means that it's 32. There is a 32 character limit, of course, but that's going to be simple. We don't need to worry about 16-bit calculation.
Yeah.
See what I mean?
Yeah.
Now, of course, if we want to read the letter A, let's look at how we do that, right? So, first of all, let's just print the letter A here. Yeah. We know where it is. It's at font start plus 8, correct?
Yeah.
Yeah. So what we'll do is we'll say load there font start plus 8. Yeah.
Yeah.
And just want to check. Everyone can see this on the stream. Yeah. It's all good. I think so. Yeah, okay, so what we're doing, we're just going to copy from font start plus 8 bytes, like that, as we did before. So it would just be load ADE, load HLA, ink A, ink D, that's it, isn't it, right? That's it. Okay, so you can think of each Yes, exactly what Burma Shave is saying there. If we went over a line, it gets complicated, right?
Yeah.
I mean, look, it's going to have to get complicated if we want more than 32 characters. So,
Yes.
if you've got 32, if you want to get 32, if you want to build a room and it's got more than 32 tiles, then you're going to have to do something with it, right?
Yeah. Yeah.
But even then, it's going to be fairly easy because it's just going to be an offset rather than
Okay.
working, right? And look, there are times when you won't worry about this. Part of the reason we're doing it this way is just because we haven't learned about how to work with 16-bit numbers much, right? So this is why it's going to be easier if we just work with these 32-bit numbers, right? So what we do then is let's just run the code, right? We'll run that we'll assemble it, right? We've got no errors, and
Well, I have.
that reminds me of Monty Python. Yes, we're all different. Yes, we are all different. I'm not. Well, inspect your code, young man. Inspect your code.
I am.
You'll find it. You'll figure it out. Right. Okay. So we're going to load
I know what it is.
Okay, good job. Right. So I just hope that the binary is there. Simple demo. I think it's simple demo, isn't it? We'll load it at 49152.
Oh,
right?
shit. Maybe not.
And we randomize. I'm put it in the basics so that we don't have to type it again. Right? So we'll go like this, and we'll run it, and hopefully that's just going to print as. And there is our letter A, right? Okay. And if we change this to 16, right? Because that's one more character along. And we do it again, and we reload it. Okay.
Label has different value in past.
That means you've got a duplicate label.
I need to get rid of the font start.
Yeah, get rid of.
Sorry.
Get rid of font start.
Yeah.
There you go. You've defined it once and then the second time. So, yeah, good.
What is going on with it?
Thank you, Mitsuyama. Right, I'll repeat that then. It's kind of visible on stream. No, just it's not fully visible. I see.
Yeah, it's one.
There we go. Nice. Right, Andy, let's make sure you've caught up with that, and then we'll carry on.
No, I've still got.
Just go through it line by line. Just go through it line by line, and you'll see.
Sorry, I've seen it. Right. Okay. What's our start address for this one?
org C000.
Which is in.
Hmm?
What is that in decimal? I need a calculator.
49152.
We're still there. Okay.
Yeah. It's just very common standard location. Nice and safe,
Okay.
out of the way of everything.
Right. Sorry about that, everyone. Right, I have an A.
That's all right, Andy. You are here to make the mistakes so that everyone else can follow along. Right, try changing it to 16, right?
To 16.
And then you'll get a B, right?
Yes, indeed.
Right. And so what you should understand from that is by adding the multiple of 8 here.
8. Yep.
You would end up with whichever letter you wanted, right?
Mhm.
Okay.
Yeah.
Now let's now look at our let's add another bit of data in here, right? So let's put here hello, right? And I'm going to put def b in here, which is define byte. We know that's a command for the assembler, not for the ZAT. And I'm just going to put the letter A in there like that, right?
Yeah.
Okay, now let's assemble.
I was playing around with some of this earlier.
All right, so let's assemble it, right? And look at what it's done. It's created there 41, which is 65 in decimal. That's the code. That's the ASCII code. Yeah? That's the ASCII code for A, right?
Huh? 41?
In hexadecimal, 41 is in hexadecimal. In decimal, that would be 65.
Right, sorry.
You can check it if you're not sure.
It's the swapping between decimal and hexadecimal, that's all.
Well, yeah, that's something you need to get used to, so. It's not 41, it's 41. Okay. Clear enough?
Yeah.
All right, so. Now then, how are we going to do this? Let's see. So what we want to do now is we want to determine the address of the letter that I write here, right? We try and print a single letter. So what we'll do now is we're gonna have to do a calculation, right?
Okay.
So, and that means we're gonna have to start messing about with the registers a little bit.
Right.
Okay. Oh no. Right. So what I'm gonna do is I'm swapping the order of these over first, simply because what I want to do now is I'm gonna do something with HL and DE to work out what the address where this letter will be, right?
Okay. Yeah.
Because I've got 41, as you said, 41 or 65, whichever you prefer, and I've got to I've got to convert that so that I can find out where it is in this list, right?
Yeah.
And then I've got to add it to the start, right? So what we'll do is this: we'll start here by saying load HL font start, right?
Yeah.
So we've put the address of our font data into the HL register.
Yep.
Okay. Now, the next thing we're going to do is we're going to load A with okay, I'm going to change it to a message so that it's a bit clearer, because we'll call it MSG, right?
Okay.
Okay. So at this point, what value is in A?
41.
Good. Okay. Now, what value do I want though? It's the first character along, isn't it? Right. So the actual value I want is 8, isn't it?
It's 8.
Because I want to add it to the address of the font start, right?
Right. Okay.
Yeah.
Yeah.
So okay, let me just be clear. You see these ones here, right?
Mhm.
Okay, so this one in bytes, right? The address of this one is is 0 because it starts from here.
Yeah.
Right? And this
Yeah.
one is plus 8, right?
8. Yeah.
And this one is
Plus 16.
16, and this one
Yeah.
is plus
24.
24, right? So what I've
Yeah.
got to do is convert. Just a second. Yeah, that's right. Well, as David's here, welcome David. He said, yeah, 40 is basically 64. So you know that if you add 1 to that, you're going to get 65, right?
Right. Yeah. Yeah.
But anyway, right? What we're doing here is we've got these addresses, and as you understand, 0, 8, 16, 24, right? And
Yeah.
here we've got these ASCII codes here, which are
Yeah.
64, 65, 66, 67, right?
Yeah.
So, and now here immediately, this is a very common challenge that you've got within when you're using assemblies. You've got like this human code here, and you've got this kind of offset here, right?
Yeah. Yeah.
And essentially, what you're looking at is you say, well, okay, what we do here is we subtract 64 from this number, yeah, and then we multiply it by 8, right?
Yeah.
Let me show you what I mean. So 64 minus 64 is 0, multiplied by 8 is 0, right?
Yeah.
Here, 65 minus 64 is 1 times 8
Yeah.
equals 8.
Right. Yeah.
Yeah? And here, the
Yeah.
answer will be 2, and the next one will be 3, and all the way down, and because we're only using 32 characters, it'll go all the way down there to 31.
Yeah.
Right? So, yeah, simple enough, right? So this formula here, minus 64, and then multiply by 8. So we load. So this is what we do then, right? We load in. Right, where are we here? Load A. For now, we just load that message. Whichever letter of the alphabet is there. We'll have to worry later on about printing more than one letter. We won't worry about that for now. Okay.
Okay.
So we load that value, right, and then we sub 64. Right.
Yeah.
Now, do you remember how we multiply by 2?
We do
The easiest way is just add a
RR.
right? Yeah,
Okay.
You're right. We can use RR as well. Yeah, we could do that. That's true. We can. And either way, we would do it 3 times.
Okay.
We keep it nice and simple. We'll just use add, right, like this.
Yeah.
It's quick. It's easy. That multiplies it by 8. Yeah.
Yeah.
Okay. So now what we do, we want to add that to the font start, but we can't. So what we'll do is well, it's a pretty straightforward thing. We'll load. Well, we just say add A to L, right? Because L is at the font start. Yeah.
Yep.
Okay. And then finally we'll go load L A. Okay.
Right.
Okay.
Yeah.
In fact, you know what? It's fairly straightforward. At least for now, for printing one letter, this is pretty straightforward. So what we'll do is we'll just put we'll put DE in here, and we'll add it to DE. Do you see where I'm just changing L to E?
Okay.
Yeah, probably should have done it. Just kept it that way to keep it simple, really. But I'll step through it again. So font start right now. Let's literally work through it step by step, right? So font start, as we know, is at C100, isn't it? Yeah.
Mhm.
Okay. So right now D equals C100. D equals C1 and E equals 0, 0. Yes?
0, 0. Yeah. Yeah.
Okay. Now, we load the address. We load the value of the message, right? And it is 41, right? Or 65 decimal. Yes?
Yeah.
Okay. Now we subtract 64.
Oh, yeah.
So now A is now 1.
Yeah.
Okay, and then we add A to itself 3 times. Now A is 8.
Yes.
Okay, now we add A to E. So
Yeah.
well, no, we add E to A, I should say. E is 0, right? And so A still equals 8 at in this instance because E is 0.
Right. Yes, we're not putting this in it. Yeah.
Okay, but
Yeah.
and then we just load. Now E equals 8, right?
Yeah.
So probably, because we've got this lined up, we don't really need to add E because it's always going to be 0 in this example, right?
Mm.
See what I mean?
Yeah.
But anyway, that's by and by what we've done. So now what is DE equal to now?
C108.
C108. Good. And if we look on here, what is it C108? On the font here, we can see C1.
Yeah.
Look. Do you see a mistake that I've made here? You see I've put my message ahead of my
Oh, after, so you've aligned it wrong.
Yeah, now it's out of whack, you see. So that's a good mistake to have made for demonstration purposes. So that is put everything out of whack. Easy mistake to make. Now the alignment is good. Anyone would think I made these mistakes deliberately for education reasons. But there you go. And now you can see there at C108, that is our letter A, isn't it? Right?
Yeah.
Okay, now that's smart because let's check it, right? We'll run it. We've got no errors. Easy enough. Let's now load it in and run it. And there's our letter A, right? But now we can use any capital letter from A to Z because we've got the room, right? So let's just put in the letter X, for example.
Mine's, hold on.
Just run it. Okay, run it, and you see? There you go.
Mine shows A. Why does mine show? Sorry, mine shows B.
Well, what have you written as your
Oh,
letter?
I know why.
Whatever letter you're
So I've still got the load D on start plus 16.
Ah, okay.
So I need to get rid of.
So that's a really common, simple calculation that you would make, especially with a table of data, which is 256 bytes. Yeah.
Yeah.
And that allows you to do what you would call 8-bit addressing of the data because it's within one page, so that it's easy and it's fast. You don't need to. And the reason that's really useful is because you notice then I don't have to change D at all. I don't worry about D, and that's good because then, if the more registers you use, obviously the less are available for other things.
Yeah.
Okay. But obviously, what we are gonna want to do here is we want to try and read a whole message, right?
Mm-hmm.
So let's see if we can do that. That's going to get a little bit more tricky, but let's try anyway, right? So what will happen now, first of all, let's go and run that and just check it. So we've got our first letter, yeah? Okay. So how can we basically read our message? Yeah. Well, what we're going to have to do is we're going to have to store our message in the registers. Yeah.
Right.
But we're already using 8DE and HL. So we'll have to either use BC, but we're using B for the loop here, right?
Yeah.
So we'd have to either free that up or we can use the stack, right? And I guess we might as well. I guess we could use the stack. Just trying to think if there's a. I mean, you know, you're gonna have to learn about the stack sooner or later. Let's see. Yeah. Okay. Well, it's 4:10. How are we doing? Yeah. Okay. Listen, the stack is not complicated, right? Sounds complicated, but it's not, right? So we've already spoken about the two places that you can store data, right? You can store it on the chip itself, right? Which is the internal registers.
Yeah.
Or you can store it in memory.
Yeah.
Okay. Now, what we also have is the stack. Now, the stack is also in memory, right? It's not in the chip, it's in memory.
Right.
But it's a kind of sort of repository for your register values. Yeah?
Okay.
So what you do is you basically say, okay, I need this in a minute. Can you just put it in memory, in this special part of memory that I've reserved especially for this?
Yeah.
And then and when I need it, I'm going to ask you for it back again, right?
Yep.
Now it's quick. It's faster than reading normal memory, much faster. Yeah. But there are some rules about what you do, and the main rule about it is that when you put something in there, you've got this thing called the stack pointer, and that tells you where the stack is at any one time, right?
Okay.
And what you're working with is you work with register pairs, and you can store them in the stack. But imagine it's like this. It's a little bit like you know when you've got an inbox, right? And you put papers in, and then you put another one and another one, and right. So you pile them on top of each other, and you can only access the one at the top.
Right.
Right? And if you want the one below, you've got to take the one at the top out first and go back in the order that you've put them in.
Okay. All
right?
Yeah.
Sounds scary, or is it all right?
It sounds like it's a faff, but yeah.
Well, okay. So essentially what we're talking about here, these two commands, one of them is called push and the other one is called pop.
Pop. Yeah.
Right? Put a register pair on the stack, right? Pop is take a register pair from the stack. Mm-hmm. Now,
Okay.
exactly where the stack is, you can define where the stack is, right? But in this particular instance, I can tell you that at the moment the stack is at the top of memory at FF4A. It's nice, it's out of the way. We don't need to worry about moving it. It's not going to get disturbed, right?
Okay.
Because you do need to be aware of where your stack is at any one time, because you know if you accidentally write data over it or something,
Yeah.
you're gonna completely mess everything up.
Okay.
Yeah, and then what you'll also have to think about is what we call balancing the stack. That just means that you make sure that however numbers you've put in, you know, when you take them out, you've got to keep everything balanced, because when you return to basic or anything like that, if you haven't returned it back to what it expects, leave everything as you find it, basically, right?
Mm-hmm. Yeah.
That's the rule. That's the golden rule of the stack, is always leave it as you find it.
Okay.
Incidentally, when you call when you call a routine,
Yeah.
well, the processor actually stores the program counter on the stack, so that when you return, it knows where to go back to.
Okay.
Right? But that's by the by right now.
Right.
Let's look at it in practice. Yeah. So what I'm going to do then is I am going to load BC here, load BC with message, right? So far that should be clear to you. Is that clear?
Yeah.
Mm-hmm. Okay, good. But the problem is that when we get down to here, we're going to use B again, aren't we?
Yeah.
And so, and if I do that, then it's going to cause potential issues with using something twice, right?
Yeah. Yeah.
Okay. So well, anyway, what I'm going to do is I'm going to take this part out of here, and I'm going to call it draw char, right?
Okay.
Still the same as before. But when I'm at this point here, I'm just gonna say call draw char, right?
Okay.
Okay. So what's going to happen is, for now, we're only dealing with one letter still, right? So we're not too worried about it. But basically, BC holds message, load the value of the message, calculate where it is, yeah, and then print it at address here 4000, right? I'm going to move this back up to the top because that's where we should begin as well, right? Because we're going to change that screen address, aren't we, when we print a second letter.
Yeah.
Okay, so when it calls this, then what it will do is it will just well, it will store where it is on the stack, and then it'll run this code, and it'll do that loop, and then it'll return, yeah.
Yeah.
And then it'll return to basic. Cool is like, it's like a go sub, you know.
Yeah.
Okay, so let's just test it and make sure. Then we should just get that letter H, make sure there's no errors. All right. Okay. So, but I'm not going to make a loop. What I'm going to try and do now is print 2 letters instead of 1, right?
Okay.
Okay. Now to do that, I would have to say call draw char, right? Then I'm going to say increase BC, yeah?
Yeah.
And then I'll just repeat what we already did, right? Which is load A, BC, and then we'll do the calculation, right? So later on, we'll actually just, we don't need to repeat this, but we'll do it just for the sake of learning, right? We're going to repeat the same thing twice. Well, I tell you what. No, do you know what? I think you should be able to handle this, no problem. Let's actually do this, right? So what I want to do here? You see this little routine here? Sub 64, add AE, load EA. Yeah.
Yep.
That's a little routine that calculates our address for the font, right? So we'll take it out.
Yep.
We'll take that out as well. Yeah, and we'll call
Okay.
that calc address. Yeah.
Yep.
And we'll put that in there, and then we'll call a ret on that as well. Yeah. So now that should be call calc address. Yeah.
Yeah.
And then call draw char. That's easy enough for you to understand, right? Everyone in the chat, by the way, is that all cool and clear for you guys as well? We're just gonna, instead of have one long line of code, we're gonna start using some calls like this.
Yeah.
And that's gonna, it's just like goes up in BASIC more or less. It's very simple, straightforward, right?
Yeah.
Okay, good. And again, you know, while we're learning, we might as well just double check, make sure that's okay. And then we'll see, right? So there we go, simple demo. And run. Yeah, we're all good, right? Okay, so what we want to do now is BC, of course, is our message, which is here, hello world, right?
Yep.
So what we'll do is we'll go inc BC, right?
Mhm.
And then we'll load A with BC again. With a new, that's now the letter E, right? And then we'll call calc address, and we'll call draw char, right? But the problem is this. This routine here, draw char, uses register B, right?
Yep.
That's no good because you can't be changing it.
Yep.
Okay, so what we'll do, with it, and you got to do this within the routine, not outside of the routine. What we'll do is we're going to envelope it essentially with the stack, right? By going like this.
Yeah.
Push BC, right?
Yeah.
Store the source message on the stack, right?
Yeah.
And then we do the draw. And then when we finished, pop BC, restore the source message address. See what I mean?
Yeah.
So, and that's it. It's just, that's how you do, when you use the stack, you're basically preserving a value that you need and then getting it back when you need it.
Okay.
Yeah, it's like
So
you're basically using it in this case. Look, there's a lot of things you can do with a stack, but in this particular case, what you're doing is you are it's like a sort of, you're insulating it from the rest of the program so that it can use B. It can use B without messing up the rest of the code. See what I mean?
Yeah. Yeah.
Yep. So it's like, okay, listen, before you do this, remember this BC, right? You can't. We don't actually use C, but it's all done in pairs anyway, right?
Yeah.
So you know, C doesn't actually get changed by this code, but B does. So we need to
Yeah.
store the whole address, right?
Okay.
So we put it onto the stack, and then we print it, and then we restore it, right?
Okay.
Okay. And now, incidentally, and we'll look at this at another time, this is also how you do nested loops, where you have a counter and you store one counter, you run a loop, and then you restore your previous counter, and then you can run a nested loop. Do you see what I mean?
Sorry, say it again.
Okay. So you know how you can use DGNZ here for B as a counter, right?
Yeah.
Well, what you can actually do is you can even put a loop. You can put a stack push BC pop BC within the loop, and then you can have another loop inside it. You see?
Yeah. Yeah.
It's like a nested loop.
Yeah.
And that way you're using B. You use B essentially for the same loop, but it's within another. If you see what I mean, right?
Okay.
Yeah, but that's again, we'll do that on another day. All we need to know right now is a nice, simple way of showing introduction to the stack, which is it's basically you're sealing it off from the rest of from messing up any of the rest of the code, because you're looking at this code and you're saying, okay, right, look, what is it changing? It's changing DE, it's changing H as well, but that's actually part of what we need it to do anyway, right? So we don't need to worry about that. We actually want it to what you could do is you could put, for example, push HL as well, because that would store the screen address. Yeah In fact, why don't we do that? Because actually what it shows you is another thing that's important, and that is that the order of these things has to go first in, first out, like this, right? Push BC, push HL, pop BC. If you did that the other way round, then what was in BC would have ended up in HL. You see what I mean?
Yep.
First in, first out.
Yeah.
Right?
Yep.
Okay. And that's actually a good idea, because you know on HL we're at the top line. When we start drawing the character, we're at the top line, right?
Yeah.
And what that will do is, as soon as you've finished the loop, it'll restore it back to the top line again. You see?
Okay.
Yeah, you comfortable with that? With the stuff?
Yeah.
Right.
Yeah.
So we'll leave that all in there, because that actually makes it easier for the code, further on up.
Okay.
So now let's look. We've gone calc address, draw the char, right?
Yeah.
And then draw a new char, right? And so what's the one thing that we need to do?
We need to increment BC.
Look at the code.
Do we need to move it along one more?
Excellent, good job. Right, okay. Because watch what will happen. You'll see it'll be too
It'll just overwrite, won't it?
Faster than the human eye, but yes.
Yeah.
We seem to have got the letter N though. That's not a good sign, because I don't know where that's come from. I don't know where that's come from, but hopefully we'll figure out what we've done wrong. We've done something wrong somewhere, but anyway. Yeah, we need to increase L, right? Yeah, we draw the chart and then we increase L. So let's see, why are we getting the letter N? We must have done something wrong somewhere along the line. We'll figure it out now. Let's see. Okay. So instead of E, we've got N. That's unfortunate.
Mm.
Let's see. So well, I'll tell you what we'll do. Let's take BC out of the stack here, right? And we'll actually put it we'll put it in here. So push, we'll store the value there, right? It could be the calc address.
Yeah.
I'm not sure what's causing the problem, but I don't know. But then we should pop it there, and that should be okay. Let's see if that works. Maybe something else was, messing with it. I don't know. Maybe it's our calculation. No, it's still doing it. How queer. Okay. So
I've got HN now.
Well, yeah, that's it. I'm trying to figure out why I've got HN as well. It's obviously the calc addresses. Yes. Well, what we need to do is we need to reset E, right?
Oh, of course, yeah.
In fact, we don't actually need it. We don't actually need this add AE, right? Because it's always going to be from 0 anyway, right?
Right.
In this instance, it is anyway. So let's. Yeah, because what we've done is we've increased E, haven't we? The source address.
Yes, and then we're just adding on to E, aren't we?
Yeah. Although quite why that? Let me just see. Did that actually work? I hope so.
Yeah, that did work.
Yeah. Okay. So there you go. So I mean, you can learn from mistakes all the time, right? And I'm more, often do. So what you would want to do is, well, if you did want to keep that in there for some bizarre reason, then you'd have to reset. You'd have to reset E back to the, well, in fact, what you do, I mean, yeah, you need to just put this in, this calc. You see the calc address, right?
Mm-hmm.
In fact, what we'll do is we'll put it in here, right? So that we can, the font, so when it calculates the address, it'll start with font start anyway, by default. See what I mean? The second time it did it, it wasn't starting from this font.
It wasn't starting from 0.
Yeah.
Yeah.
All right.
Yeah.
Okay. So that's easy enough, right?
Yep.
Now let's see if we can basically let's put a loop in there now. Then how are we gonna put a loop in there? Well, could get complicated, but I suppose yeah, I tell you what we'll do. There's a pretty simple way of doing this, right?
Mm-hmm.
What we'll do is there's a couple of different ways we can do it, but let's say we go to
so far.
Okay, I'm gonna put, for now, just to keep it simple, right? I'm gonna put a letter like a marker something like this at the end. There are different ways that you would do this. You wouldn't normally use one whole character to do this, but for the purposes of this, I think it should be fine. So, well, just a second. Let me think about that, because I haven't. Okay, so I'm gonna. Okay, this is what we'll do. We'll put it as a loop like this, right? Message loop. We'll start from here, yeah? Andy, yeah?
Yep.
Okay, and what I'm going to do is instead of calling that there, we're going to just check and again, we're going to do a comparison. We haven't talked about comparisons, but we'll do it very quickly, and then we'll talk about it a lot more next week. So it's a nice simple introduction, right? So what I know is, well, actually no, I'll tell you what we'll do. This is a nice simple thing. Look at, you see the message?
Yeah.
Right, so what I know is that after hello world, after the message hello world, is going to be the value 0, right?
Okay.
So all I need to do is check if the value is 0. Okay, and I'll use a compare to do that for today, but next time we'll talk about flags. Yeah, I know we've spoken about them before, and flags can be the full focus for next time. But essentially what we're going to do then is this. I'm going to load A with BC. I'm going to compare it to 0, right? There are other ways of comparing. You don't normally do compare to 0, but we'll do that, yeah? And then basically I'm going to say jump or jump regular if not 0 to message loop, right? Okay, now that's another, making comparisons, we'll do it properly with the flags and everything, we'll do it next week, but essentially all you need to know is this. We calculate the address and we draw the character, right? We go one line across, we go to the next character, and we look at what that character is. And if that character is not 0, that means our message hasn't finished, yeah? In which case we return to our message loop, and we put the next letter, and we keep going until we encounter, as you can see here, hello world is 48, 45, and eventually it's going to hit 0. And when it hits 0, that's when we know that the message is finished, right?
Yeah.
And then when the message is finished, we're just going to go back to basic, right?
Yeah.
Okay, so let's try it. As I explained to you, compare is like a subtraction without actually subtracting. So you get a 0 sum. If you get a 0 sum, it's a bit like in accounting, you know, when you get a 0 sum, that means it's equal, right?
Yeah.
And so that's what you're asking it, you know, did you get a 0 sum for that? And if you did, then
yeah, that works. Apart from we don't have space defined, so we get an @
yeah, we do indeed. Yeah, nice. So let's solve that problem next week as well. Because we could check. We could do a check on that, you know, for that particular value. But you can see why. You can see why we get that @ can't you?
Yes. Yeah.
And a very simple way of fixing it. What would that be?
Do a compare on that.
No, just hack the @
No.
symbol and turn it into a space.
Okay.
Right?
You could, yeah.
That's the, that's the easiest. Although if you're using the ROM, you wouldn't be able to do that, but we're not, so we
Yeah.
can. Right? There you go. Look, I've just changed it.
Yeah.
It's a space. It doesn't matter, you see. As long as
Yeah, true.
it interprets it that way, then it'll interpret it that way, and that's it. I mean, there's lots of
Yeah.
different solutions, but that's by far the simplest in this case.
Yeah.
Yeah, so you just go like that, or you just go, Andy is skill. Specky rules. Right? I hope that's not 32 characters. It might be. Maybe not. Probably not. There we go. And there you go.
Yeah.
And as I'm sure you'll have figured out, you can go back to ZX Paintbrush if you want, and you can, these are fully customizable fonts, aren't they? I mean, it's
Yeah, yeah, yeah.
So if you want to kind of edit the font
Yeah.
so that you get a different
Yep.
result, I mean, if you were to, I guess if you were to put 3C in here like that, then you're going to change the letter A to whatever. So you basically, instead of last time we only had one control over one character, right? But now we've got control over 32 characters.
Yep.
And actually, we've really learned quite a lot today. There, you see, look, see how I've edited that A there?
Yeah.
Cool. Great.
Yeah.
Well, that's plenty, isn't it? But that's it. So what?
That was a lot.
Yeah, it was. But then again, it wasn't wasn't a disaster, was it? I mean, we learned quite a lot of nice things about this, though, right? That's like a lining on a table. We've got data there, 256 bytes of data that we can work with. We could, and we may look at that next time, how to use the whole font, 32. Instead, 768 bytes maybe, right? We learned about a little bit of basic maths to do some calculations to convert ASCII code into our address. And we learnt about the stack, which is not, stack's not so scary, is it?
I'm sure it gets much more difficult than that.
Well, it really honestly doesn't, other than the fact that you have to try and... No, you just have to keep track of it, right?
Okay.
Sometimes you'll find yourself going, how many pushes or pops have I done?
How many pushes have I made? Yeah.
And what you'll find is you'll get a crash, and one of the big reasons you'll get a crash is because if you put one too many pushes or one too many pops, if it's out of balance, then when you run a routine, it'll return to somewhere that it isn't supposed to be. Because it uses it uses it for that as well. But it isn't. No, it really isn't that complicated.
Okay.
And you can do. I mean, you can also, if you want to copy a register from one register to another, one option is to say, if you want to copy HL to say DE, then you can do that. You can actually do that, right? And now DE will equal HL because you've put it on the stack and you've dragged it back again. So,
right. Okay.
Yeah, but essentially, the stack, that is what the stack is for. You just it's like it seals things off so that you can, for example, when I don't know if David's still here or not, but like when you have an interrupt routine and it's playing music, right? It's like a totally separate bit of code that's going to run. Yeah.
Yeah.
And generally, what you do when you run an interrupt routine is you will you'll actually I'm not sure if I've got an example here. I think I probably do. Just a minute. I'm not sure if there's maybe there isn't music on this one. This is Attic Attack, by the way. We're looking at the source code for Attic Attack. No, maybe that's not. Oh, but no, I can show you one. I can show you one on DK, right? So you see this here, right? You see you've got all. It looks really scary, yeah. But it's like push, 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 da da da, pop, 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 yeah.
Yeah.
But actually, all it's doing, you see that routine there. It's calling that routine, and all this is doing is it's just preserving all the stacks. Preserving all the registers on the stack. Yeah.
Yeah.
And then running the routine, and then bringing them all back again.
Okay.
That's all it is. And that's what you do when you're running interrupts. You protect all your registers so that the interrupt routine doesn't mess with anything that you're in the middle of.
Right.
So that when it goes back again, everything is exactly as it was.
Okay.
Yeah. It's like anything. It's like, in your job, you go to someone's office, or you're gonna borrow someone's computer or something. Then you just leave it exactly as you found it, so that when they come back, they don't feel like there's been any difference. It's the same as that, really.
Okay.
No, I promise you, you'll be waiting for things to get really bloody complicated, but they're not that complicated. They honestly aren't that complicated. It's just it's very detailed, tiny little pieces of things.
Yeah.
That's all.
Yeah.
Cool. Well,
Okay.
I think that's been a good stream. I've enjoyed that tonight. Yeah.
Yeah.
And
learned a lot.
We'll just see if so for all of you guys that are watching, again, don't be afraid to just mess about with it. Change a few things and just have a go. It's easy. It's you can't break it. It's easy to do. And next time we'll look more closely at flags and conditions, right? So how certain calculations that you make, certain arithmetic functions that you perform, let's say, will trigger certain lights to come on or off within the CPU, right? And you can detect those lights going on or off. There's only really two that you need, to be honest, for almost everything. And then you can cause the program to do something accordingly, right? So and essentially that's going to allow you to check if something is equal to something else, if something is greater than something else, and if it's less than something else. And that's more or less all you need for pretty much anything in a computer game. Right?
Yep.
Those simple tests in combination with each other, Cool. All right. Well, let's call it a night there then. Thank you, everyone who's been on the stream tonight.
Thanks, Sol.
It's been a pleasure as always. We haven't had as much banter and chat today, but we did have a nice chat about that game. And shout out to Angel if he did watch. I know his English isn't that great, but he said he might tune in. And let's reconvene hopefully next Thursday. I should be in my new flat by then. Finally. And as always, happy coding. Take care. Bye bye.